Okay, so yesterday we talked about finding the greatest common factor, right? I give you 2 or 3 or 4 or 5 numbers, and I ask you to find the greatest common factor, right? That's not the end all. The end all is there's more to it. Once you find the greatest common factor, you can then factor it out of the original expression. Right, so guys, I'm going to ask you to put all the paper airplanes away. This is my lecture. I've asked you to take notes, okay? I want you to be writing things down. I want you to be listening to what I'm saying, okay? And no drawing or anything right now. I just want you to really be focused. This is really important to get. Everything, all of higher level Algebra 1 centers around understanding this concept. Okay, I'll get it.
Foiling?
I'll just get after it. What?
Like foiling?
Like foiling, exactly.
I learned that
And in order to do foiling, you have to know how to do this. This is actually an aspect or one part of that will allow you to
learn that.
Oh yeah, you will be foiling probably in a couple months, maybe less. Factoring out the greatest common factor. So the first thing is you got to know what the greatest common factor is. So if I give you something like this, 3x plus 21, I need to know what is my greatest common factor between 3x and 21. And I could use the upside down birthday cake method, but my guess is most of you know.
Yes.
Right? Most of you could probably do that in your head. Let's see. They don't both have x's, so there's no common x factor. There's no greatest common x factor, right? Because they don't both have x's. The only time I can have a greatest common factor is if that number or variable is in both of the terms. There's no x in this one, so I can't take out an x. So all I'm going to look at is the numbers. I have a 3 and a 21. What number goes into both 3 and 21? 3, right? 3. Right? That's the only number that goes into 3 and also goes into 21. If I said 9 or 7, well 7 doesn't go into 3. Right? It goes into 21, but it doesn't go into 3, so that's automatically out. So everybody agrees that 3 is my greatest common factor? Yes? Fist of 5 for sure? Everybody gets it? Right, and I'm giving you an easy one, fairly easy one right now. We'll work our way into harder ones. So now what I'm going to do, when it says factor out, think about what factors are. If I said, what are factors of 10? Well, I might say 2 times 5 or 1 times 10. What do I put between the numbers? A multiply. So I'm going to do a multiply, but when I factor like this, I'm going to use a parenthesis. Because this is a binomial. Do you know what a binomial is? How many terms does this have? 1, 2. Remember, terms are separated by pluses or minus signs, right? So there's a term, there's a term. There's 2 terms. 2 terms, bi means 2, right? Binomial, nomial means, I think it's Latin for number and stuff. So 2 numbers, binomials. What?
You have like a hexanomial?
I haven't heard of one. Usually, once you get past trinomial, they usually just call it polynomial. But it would make sense. I mean, I would know what you mean by that, and so it's it's fine. But so 3 times what is equal to 3x? 3 times. Does everybody agree with that?
Yes.
3 times x would equal 3x. Okay. Plus 3 times what would equal 21? 7, right? And I close my parenthesis, and I have just factored out the greatest common factor. My greatest common factor was 3, and if I multiplied 3 times this x plus 7, I should get back to this. And I can always check my work. Here's my check. I'm going to check by I'm going to do my 3 times x plus 7, and I'm going to do my distributive property. 3 times x is 3x. 3 times 7, there's a plus sign. 3 times 7 is 21. That's the same thing. I got it. I know that I just got 100% on my quiz because I just checked it. And I know it's right. I have no question. Sally, you have a question?
So it's kind of like dividing the The thing by the greatest common factor?
Yes. So there's two ways. Once you find your greatest common factor, there's two ways to think about it. You can either think of it in terms of multiplying, or you can think of it in terms of dividing. So we did it. I did it when I was teaching it to you. I was saying multiply. 3 times what is equal to that, right? But I could have said 3x. Everybody looking? All right, everybody following? 3x, Serena? 3x divided by 3 is equal to x. Remember, think about it. 3x divided by 3 is equal to, look, the 3's crossed out. So I have x. So there we go. 3x divided by 3 is x. So if you are more comfortable with dividing, then you can do that. 21 divided by 3 is 7. Okay? Or if you're more comfortable multiplying, 3 times what is 3x? 3 times what is 21? Right? See what I mean? Okay? So let's try it. Let's try a few. It takes a little getting used to, but once you do it, once you get used to it, it makes a lot of sense. And it will open up a world of possibilities in solving things in math. So let's say I had 5x plus 25. What is my greatest common factor? Elizabeth?
5.
5. Right? There's no x here, so I can't take out an x. Whatever I take out, it's got to be in both of them. 5 is in both of them. So 5. What would I put here? 5 times what is 5x? What? Right? Is everybody with me on that? 5 times x is 5x. Plus 5 times what is 25? Great. And I can check it. 5 times x is 5x plus 25. 5x plus 25. Yes, we're right. I know I got 100% again on my quiz. Yes, Jeannie.
What if you have a problem that's all variables, like a plus a, b?
Okay.
Oh yeah, that's perfect.
So let's try something like that. Let's say we had, I think, ab plus b squared.
Yeah.
Right? All right. What is my greatest common factor? Is there? Could it be an a?
B.
Could it be an a? There's an a in this one. Is there an a in this one?
No.
Then it can't be an a. We can't have a in my greatest common factor. All right. There is a b here and there's a b squared here. So b and b squared. Which is my greatest common factor? B, right? It's got to be the one with the smallest exponent. So I'm going to write my b here, and then I do my parenthesis. B is my greatest common factor. So b times what is equal to a times b?
A.
Right. B times a is equal to ab, right? And then I do bring down my plus sign plus. B times what is equal to b squared?
B.
B. Remember, b times b is b squared. X times x is x squared, right? Right? So and I'm going to just check it. I'm going to use my distributive property. B times a is a, b, or ba. Doesn't matter which way I write it, a, b, or ba. Because multiplication is, does anybody remember that property? Commutative, right? It can be either way, right? A, b, ba, doesn't matter. They're the same thing. ab is equal to ba. So that's right. Now b times b is b squared. Yes, there we go. We did it. Right? All right, so let's try another one. Let's try 12x to the 4th plus 36x. All right, now for just the numbers first. 12 and 36. What's my greatest common factor?
12.
Oh, 12 goes into 36, doesn't it? 12 times 3 is 36. Can you see okay? 12 times 3 is 36. So I know 12 is going to be part of my greatest common factor. Now, I also noticed this has an x to the 4th, and this has an x to the 1. So which is my greatest common factor of the x's? X, right? Just plain x, right? All right, so now I'm done. That's my greatest common factor. Now I'm going to put my parenthesis. And I'm going to say 12x times what equals 12x to the 4th?
X to the 3rd.
X to the 3rd, right? Think about it. X to the 1 times x to the 3 is equal to x to the 1 plus 3, which is 4. right? These exponents have to add up to this exponent. Does that make sense?
Yep.
That exponent, 1 plus 3, has to equal this exponent, 4. Yes?
Couldn't you just put 12 outside the parenthesis and then just put x to the 4th in there?
No, because it's not the greatest common factor.
Right. You're looking for you're looking for the greatest common factor. There's not an x to the 4th here. I can't take out an x to the 4th out of this, right? I can only take out, for the variables, I can only take out the smallest x that I have. Because both of them will have, this has 4 x's multiplied times each other. This has 1x. I can take a 1x out of this and 1 out of the 4 out of this. But I can't, I can't make my greatest common factor x to the 4th because I don't have x to the 4th here. I can't take out.
Your GCF would still be 12.
No, but your GCF is 12x.
Oh, I see. It's 12x. Right. The reason is you're trying to simplify everything, both numbers and variables. You're trying to find the total, the largest greatest common factor. If I had just said 12, that is a factor. It's a common factor, but it's not my greatest, my biggest common factor. My biggest common factor is 12x.
Yeah.
See what I'm saying?
Yeah.
I mean,
But if there wasn't an x there and it was 12, no.
if there wasn't an x here, then I could say 12.
Yeah.
Right, exactly. So we got that. Now I've got a plus sign here, so I'm going to bring that plus sign down. And then 12x times what is equal to 36x? 3, right? And I'm done. Now I'm going to just check it. 12x times x to the cubed is 12x to the 4. Yes, that's right. Plus 12x times 3 is 36x. Yes!
Yes.
We did it. Does that make sense?
With an elephant.
Right? Is it making sense?
Yeah,
All right.
we got to use elephants.
So this is what I think it's less than 35 is about. Isn't that right?
Yeah, we did.
Am I right? 35 or 36, one of the two.
And also last night was penciling.
And now, yeah, no. Let's make it. The Saxon loves to do the hard ones right away, and I disagree with him on that personally. But let's do a hard one, and you'll see it's not that bad. Let's try 6x squared y to the 5th plus 36x to the 6th y squared. All right. What is just the number? I'm just looking at the number first. 6 and 36. What is my greatest common factor? 6. So I write a 6 here. Now, just looking at the x squared, or the x squared and the x to the 6, which is my greatest common factor? X squared. So I write x squared. Now, just looking at my y's, y to the 5th, y squared.
Y squared.
Y squared. Now I put my parenthesis. That's my greatest common factor. So now I'm going to say, okay, 6 times what is 6?
36.
Well, 6 times what is 6? 6 times what? 1, right? I don't need to write the 1, but I will. 6 times 1 is 6. All right, x squared times what is x squared? 1, and I've already got the 1 there, so I'll just leave it. Right?
Yep.
So 6x squared times 1 is 6x squared. Now what about y squared? Y squared times what is equal to y to the 5th? Y to the 2 plus 3 is equal to 5. There we go. And then plus, bringing down that plus sign. 6 times what is 36? 6. X squared times what is equal to x to the 6? In other words, 2 plus 4 is equal to 6. Right? I'm just adding my exponents when I'm multiplying like that. And the last one, x squared times what is x squared? Just 1, right? 1 times 6x to the 4th is 6x to the 4th. So I don't even have to write my 1 again. I'm done. It's not that hard. Just a little trickier because you have 2 things you got to work on. But I do 1 at a time. Right? You guys get that? Yes. Great.
What if it was like 6x squared, but like 6x, like it was the same thing, but except at the end there wasn't y.
Right here?
Yeah, like.
If I didn't have that y there?
Then y wouldn't
Alright.
be part of the greater common factor.
So, exactly. So if there wasn't a y there, now suddenly I can't have a y here because there's not a y in both my terms, right? So that would be my greatest common factor, right? And if that were the case, then I would do my parenthesis.
It'd be y.
It would be
5.
6x squared, 6x squared, so 1 y to the 5th plus 6 times 6 is 36. X squared times x to the 2 plus 4 is 6. There we go. That's your answer, right?
Wait, do you have to write one?
You're welcome. What?
Do you have to write one?
You don't have to write one. I'm just doing it because some people, I think, need it.